Now we are starting, as I have told you about the atomic number and mass number, electronic configuration, valency, valence shell, everything we have done. So now we are taking up isotopes and isobars. What are they exactly? See, isotopes are, one more thing I want you to know. You know, we have studied in Dalton theory. The drawback of Dalton theory was it was said that Dalton said, actually Dalton formulated in atomic theory that the element contains atoms and the atoms are similar in shape, size, all properties, they are alike. They are same to each other. We have done this, right? And he said the atoms of different elements are different, but it was the limitation we did in the limitation that Dalton was actually wrong. Like, that means the atoms of different element can be same and atom of same element can be slightly different also from each other. So from where does this limitation came from? You know, the limitation came from due to the existence of isotopes and isobars in nature. You know, in nature isotopes exist. That means these isotopes, what are the isotopes? Now the question comes in your mind that what are actually the isotopes are. So first we'll take up this and then we'll discuss what the Dalton said and what was the limitation, how it was concluded or like that. So what are the isotopes? Isotopes are actually the atoms of an element which has same atomic number but different mass number. So that means, see, I'll take an example, then this will be clear in your mind. See, carbon exists in nature as this and this mass number, atomic number, and you must not be knowing, or you must know, you may know that carbon also exists in nature as this. So that means, but in your regular topics you are taking carbon as C12, but we do get C14 also, that means carbon element with 6 atomic number but mass number 14 also in nature. So that means, what are the difference between it? See, they have same atomic number but they have different mass number. Same atomic number means, atomic number corresponds to, see, atomic number is 6, that means number of protons are 6. Number of electrons are 6. Configuration, the both atoms will have the same configuration 2 and 4, the same valency, everything is going to be same, right? Then where does the difference lie? The difference lie in the mass number. Mass number we know is actually the sum of proton and neutron. Proton is atomic number is same, so protons, that means, are same. So in which aspect they differ? They differ in number of neutrons. So there is a difference in the number of neutrons. That is why these atoms are called as, the relation between these atoms are called as that they are isotopes. Isotopes means, I think I've written a wrong spelling. So see, it is isotopes, I-S-O-T-O-P-E-S. So that means that the relation between these atoms, they are isotopes. Isotopes means the atoms of the same element. See, they are the atoms of the carbon element, the same element, which has same atomic number but different mass number. So that means that the similarity between them is they have same atomic number, they'll be having the same symbol because the symbol corresponds, the atomic number corresponds to the symbol. So if atomic number is same, symbol is also same. So they have same symbol, same atomic number, same number of protons, same electrons, same configuration, same valency, and even all the chemical properties will be same because chemical properties are determined by the valency, as I told you in the previous lecture. So that means these are all similarities which they will exhibit. Now, what is the difference? The difference lies only in the number of neutrons. They differ in only number of neutrons. So these are isotopes. Few more examples I'll list for you. It is not only the carbon that exists in isotopic form. There are so many elements which exist in isotopic form. That means their main form is something, and they also exist in different mass number, whether it is in traces, but they do exist. So I'm writing few examples for you. Let us list those examples. See, it is for the case of hydrogen also. Hydrogen exists in nature in 3 forms, all with same atomic number but mass number as this. Isotopes actually don't have the separate names, like this will take, if I want to address this carbon, I'll say it is C12, that is the carbon element with 12 atomic mass. If I want to address this, I'll say it is C14, that means the carbon element but with 14 mass number. But it is an exception that we have name for hydrogen. So what are the names? We call H11 as hydrogen with 1 atomic mass as protium, with 2 as deuterium and 3 as tritium. So otherwise the isotopes don't have separate names. They are called with we can call them, we can address them by using the name and the mass number. But for hydrogen we have names. So remember in mind, it is you can say an interesting name that the isotopes have different names. In case of hydrogen, protium, deuterium, tritium. Hydrogen with 1 mass number protium, 2 mass number deuterium, 3 mass number it is tritium. Similarly, we have few more examples, not names, only examples. That is, we have for uranium, we know uranium is U, 92 atomic number, mass number as 235, 238, and it also exists in nature as 239. The percentage is very low, but still it exists. You may not find this example in many books, but it do exist. More example I can list for you is case of oxygen. We know the atomic number, they are going to have same as their isotopes, same atomic number, mass number as 16, 17, 18. The most percentage that of the atom which is found in nature is O16. Similarly, in this case it is U35 and in this case it is H11. So similarly, you can have the many examples for the isotopes. So got it? Isotopes are those which are atoms of same element which have same atomic number but different mass number. Similarities being same atomic number, same symbol, same proton, same electron, same configuration, same valency and even same chemical properties. The difference lies only in the number of neutrons. So now we are taking up the isobars. Now what are isobars? Isotopes we have seen, the same atomic number, different mass number. Then what is the speciality, or you can say the difference lies in the isobars. So isobars are again the atoms of an element, atoms of different element. They are not atoms of the same element. They are atoms of the different element, because Dalton said the atoms of different element are different. But this isobar shows that the different element can also exhibit a certain kind of relation in them. So look at the board, I am going to explain you. Isobars are the atoms of different element that have same mass number but different atomic number. For example, I take an example, it will be clear in your mind then. We have calcium and argon. See, you can look for the symbols. By looking at the symbols only, you can say that this is calcium, this is argon. So how can they be similar? But still, the atom exhibit a certain kind of similarity. What is that? They have the atomic number for calcium is 20, you all know, and for argon it is 18. But you know, the mass number is similar. So when any atoms of different element has same mass number, the relation they have, they are called as isobars. So now we will list the similarities between them. First we will list the difference, because there are a lot of differences which are existing between them. So what are the differences? They have different symbol, as you can see. For calcium it is Ca and for argon it is Ar. Different symbol means different atomic number. Different atomic number means different number of protons. As we know, number of protons are equal to number of electrons. So that means they have different number of electrons as well. So that means electronic configuration is different, and likewise the valency is different, and if the valency is different, that means chemical properties are going to be different. So these are the differences actually which they actually, when we compare them, the difference is what they actually have. But now what is the similarity? The similarity lies only in they have same number, same mass number, and we know mass number is formed of proton and neutron. Proton are actually different in them. So what similarity they have? The similarity is neutron. They have similar number of neutrons. And this is the factor which make them relative to each other, that they are isobars. So this is how you can write, you can see the relation between different atoms, that you will see that the different atoms of an element, different element atoms can also be alike in some aspect, and the same atoms of an element can be different in some aspect. So this shows when the same element atoms are different, the relation is isotope. When different element atoms are similar, it is the isobar. So this is how we have explained it. You can look for the more example, just looking at that they have same number of neutrons. You can look that you can say that they are isobars, and if they have different number of neutrons and same number of protons, or you can say the same atomic number, that means the relation is